Hi learners, now we are going to study demineralization process. What do you mean by this demineralization process? First of all, you should understand, you should know demineralization process or otherwise said to be ion exchange process. What do you mean by demineralization? DE stands for removal. So removal of minerals from water is said to be demineralization. Okay, so here we have this treatment called external treatment. So this demineralization process comes under external treatment. That means before sending the water inside the boiler, we are going to treat the water and send. So that means externally we are doing this treatment. Outside the boiler we are treating, isn't it? It is called external treatment. In this process, this the diagram here shown is there are two exchange towers. So one is cation exchange tower, and then other one is anion exchange tower. This cation exchange tower will contain cation exchange resin, and this anion exchange tower will contain anion exchange resin. The cation exchange resin is nothing but carboxylic acid or sulfonic acid. This anion exchange resin will contain hydroxyl ion and amine, etc. And here we are going to pass the raw water, which is assume that raw water is going to contain calcium chloride. And if this calcium chloride is interacting with the resin, you know what happens actually, the resin will contain H plus ions. So those H plus ions will be given off, and then the calcium and magnesium ions, or that means all the cations which is there in the raw water will be absorbed here. So the cation exchange resin will trap out all the cations. Okay. Now the cations free water will enter into the next tower, that is anion exchange tower. Here the resin, that anion exchange resin, will trap all the anions, will trap all the chloride, sulfate ions which is there in the water. So if all the anions have been trapped out, only the deionized water or demineralized water will be sent out. So please understand here, the cation exchange resin will remove all the cations. Anion exchange resin will remove all the anions. Now the water which is free from cations and anions, that is nothing but demineralized water or deionized water will be sent out. Now imagine the resin is completely empty. Okay, that time we have to close the raw water supply and we have to open the dilute HCl which have been kept in the left hand side tank, and then dilute NaOH in the right hand side tank. So when you pass this hydrochloric acid, the cation exchange resin will be activated, will be reactivated. And then if you pass dilute sodium hydroxide, the anion exchange resin have been what again regenerated. So that means the regeneration of cation exchange resin and anion exchange resin will be come into role by adding a dilute HCl or dilute NaOH. See, the advantages in this method is the alkaline and acidic water also may be treated, and it produces the water with holding the very low hardness. And some few what is that disadvantages are also there. This equipment is costly, resins are expensive, and if you go for the turbid water cannot be treated in this method. And not only that, you know, if water is containing iron or manganese, those metals, the transition metals will actually block the active sites of the resin, and which reduces the efficiency of this unit. This is about ion exchange process or demineralization process. And here we have a note called resin folding. See, we have used this cation exchange resin as well as the anion exchange resin, isn't it? And this resin will undergo degradation or decay, or it undergo a process called folding. So that means actually so many chemicals will go and destruct the particular resin. Okay, so now we have different types of this. You know, the chemicals will are microorganisms which is going to fold the resin. So the very important the type is folding by bacteria and algae. Next one is folding by iron and manganese. The third one is folding by organic species, and also folding by oil happens.